In this program, we're going to deal with 3 challenges in transportation that engineers must meet: car safety, construction of a runway in the far north, and consolidating a bridge. Do you know that 1 person out of 2 will have a serious car accident in their lifetime? The least I can do is to drive defensively, as they put it. That means first buckling up, fastening my safety belt. There are still all sorts of misconceptions about safety belts. Some say you'd be better off to be thrown from a car than to be stuck inside it. Well, it's simply not true. Whatever the speed and wherever you're driving, safety belts are your best protection. Automobile manufacturers share our concern for safety. They know that the greater a car's performance, the safer it has to be. The automobile rules the highways of the world. We have become dependent on that form of transportation. When an accident occurs, more often than not, we attribute it to the negligence on the driver's part, rather than to a fault in the vehicle. True, neglecting to buckle up is very often the cause of bodily injury in a highway accident. But the way a car is designed can make the consequences of a collision much worse. Injuries sustained in an accident are caused by a transfer of energy from the vehicle to its occupants at the moment of impact. A moving automobile is animated by a form of energy called kinetic energy. When the driver brakes, the kinetic energy is transmitted to the car's brakes, where it turns into heat. The car stops. In a collision, on the other hand, the car's kinetic energy is not transmitted to the brakes. Some of that energy causes the body of the car to become deformed. Some of it is transmitted to the occupants of the car. Thrown forward, they may hurt themselves against the interior of the car. If they are not wearing their safety belts, they may even be thrown out of the car. The seriousness of the injuries depends on the speed at which the car was traveling before impact, and also on its design. A car whose body is extremely rigid will stop almost immediately upon impact. Most of its kinetic energy will be transmitted to its occupants. The car may not be badly damaged, but its passengers could be seriously injured. There are other features that affect a car's security. Spacious passenger cells, for example, often provide better protection. Moreover, in a number of countries, cars must conform to strict safety norms and are subjected to many tests. One of these tests consists of staging a real accident under well-controlled conditions. This type of test is carried out in a building fitted with an acceleration ramp and a buffer. The car to be tested is carefully prepared. Mannequins made of metal and synthetic materials are seated in it. They are fitted with sensors in order to measure the movements and the forces they will be subjected to upon impact. The performance of the mannequins, whose weight and size correspond to the average person's, is an indication of what to expect in the case of real people. Sensors are also placed on the safety belts as well as in various places on the car. The various measuring devices are connected to a main cable. This umbilical cord transmits data from the apparatus to the control room. In this room, the data obtained is recorded on magnetic tape and computer analyzed. The final preparations consist of applying a coat of blue paint inside the car. This will indicate where the mannequins strike the sides of the car. The mannequin's temperature is measured. It must remain stable throughout the test. The high-speed cameras are given a final check. They will film the collision. An electronic flash, triggered by switches on the bumper, will activate certain devices precisely at the moment of impact. The car is finally pushed to the beginning of the acceleration ramp, then attached to steel skates that ram it into the buffer wall. The car hits the wall at a speed of 48 kilometers an hour. The cameras and devices installed in the vehicle provide valuable information on the performance of the car and the effects on its occupants. The driver's head often bashes into the steering wheel. At a speed of only 48 kilometers an hour, the force of deceleration sustained by the passengers in a brief moment can be 10 times greater than the force of acceleration of a rocket lifting off. The compression caused to the occupant's limbs and chest by the deceleration is equal to hundreds, even thousands of kilograms. A great deal of information is collected after the collision. Researchers make sure that the windshield doesn't give, as this would expose unfastened passengers to ejection. The car is fitted with a special device to detect any gas leaks. The standards require that any such leaks be absolutely minimal, as they could cause serious fires. Many security tests are made on cars. Some contribute to reducing the numbers of accidents on our highways, others to lessening their disastrous consequences. I hope I haven't turned you off traveling. A car can be smashed into an accordion so easily. It's really nothing more than a metal frame and can be quickly converted into a pile of scrap. It seems that manufacturers could make even safer cars, but they would be much more expensive. Would you be willing to pay the price? In our society, another means of transportation rivaling the car in terms of popularity is the airplane. Restful, reliable, and so much faster. And there are airports all around the world, even in the most remote places. While these airports may be less impressive in terms of size, they play an important go-between role. It is largely to the airplane that we owe the development of the far north. The first planes landed on makeshift, barely marked out airstrips. Today, there are real airports, but the engineers who built them had to use every bit of their ingenuity. At the far reaches of the globe's boreal regions extends a vast, virtually barren land, the far north. Over millions of square kilometers of rock, tundra, and ice, ruled by cold, wind, silence. Since the beginning of time, life has somehow found refuge in such inhospitable regions. Communities of people settled there and learned to adapt to the harsh conditions. For a long time, without roads linking them to the south, these people, such as the Inuit of northern Canada, lived in isolation. Today, thanks to the development of air transportation, that isolation has been broken, and the Inuit now have access to the conveniences of modern-day living. However, to set up a regular, efficient, and safe air communications network, reliable airports have to be built. Building runways that can take on heavy air traffic year-round in remote far north regions is a major challenge. To choose an appropriate site, an aerial survey of the terrain is conducted. All geographical features of the land are taken into account to ensure maximum landing and takeoff security, especially at night. Other important considerations are the direction of prevailing winds and the formation of fog. Even in summer, Arctic weather can make a takeoff or a landing most precarious. Construction begins with the transportation of all the materials by sea. Around mid-July, the water is finally freed of its winter ice, and vessels are able to come in close to shore. During the 4 or 5 day unloading, tugs ply between the ship and the shore. This sea bridge is essential to the undertaking's success. Any delay could compromise the entire operation, as the construction season lasts 4 months at the most. On the site, other difficulties await the work crews. The first being the scarcity, along northern coastal areas, of gravel, which is an essential component of runways. The rarity of gravel is the result of the passage of the huge glaciers, which, as they slowly progressed, carried away any rocks and pebbles. To obtain gravel, the crews have to resort to drastic means. Stuff a rock hill full of dynamite, blast and reduce it to gravel using crushers. The building of a 1,065-meter runway requires the production of 500,000 tons of rock and gravel. Before the granular material can be laid down, the designated area must first be leveled. But this stage also presents difficulties. In the far north, the subsoil is completely and permanently frozen to depths of several meters. The soil, 40% of which is ice, is called permafrost. Only a superficial layer of permafrost, a few centimeters thick, thaws in the summer, allowing some life to grow. If the permafrost is bared, the ice in it for over thousands of years begins to melt. Normally as hard as rock, permafrost then loses its consistency and collapses. Moreover, the water, unable to drain away, accumulates and stagnates. To prevent the permafrost from thawing, the runway must be covered with a layer of insulating material, such as synthetic foam, which prevents the heat from reaching the frozen ground. The airport complex buildings adjacent to the runway are, for their part, built on piles. This permits a layer of cold air to circulate between the floors of the buildings and the ground, thus insulating the soil from the heated areas. Also, to prevent the permafrost from thawing, any water must be able to drain off freely. Water has the capacity to absorb large quantities of heat. If it were to accumulate along the sides of the runway, following a snowfall or a spring thaw, the heat it holds could be transmitted to the permafrost. To drain the water off, deep trenches are dug along either side of the runway. In some cases, a geotextile covering is unrolled over the runway. The synthetic textile is highly resistant and prevents any small particles from shifting, keeping the runway stable. Once these difficulties have been surmounted, the runway is covered with fine gravel. A plane can now land, inaugurating a regular airline link with other northern cities and with the major southern centers. Construction of any kind in the far north has to take Arctic weather conditions into account. There are engineers who, as a sign of peace between the Americans and the Russians, dream of building a bridge over the Bering Strait. The cost of building such a bridge has been evaluated at $4.2 billion US. Is that too much for a symbol? Actually, the bridge is a symbol of communication and a testimony to man's capacity to overcome obstacles. Not surprising, then, that the collapse of a bridge is considered a tragedy. The Tacoma Suspended Bridge, for example, in the United States, was a masterpiece of lightness until unexpected yet moderate winds arose. The bridge collapsed. That was in 1940, and the history books are there to remind us of it. But boats also represent a threat to bridges, especially when the bridge's pillars are set in the navigable areas of a river. Reinforcing the pillars is then a Herculean job. Bridges are among man's most audacious accomplishments. Gracefully overcoming nature's obstacles, they are the essential links in the world's network of communication. But bridges can be struck by disaster. Thrown over waterways, for example, sea traffic threatens them. A ship which has veered off course can ram into a bridge's pillars, sometimes causing a major disaster. Here, studies have shown that this bridge, straddling the navigable St. Lawrence River, ran the risk of a major accident once every 40 years. Such a risk far exceeds the acceptable standards, which are once every 1,000 years. This high risk was due to the bridge's structure, which rested on very narrow columns. The chances of the bow of an off-course ship ramming into the water-level portion of one of the columns were great. Such a collision could have been devastating. To lower the risks, a solution was found. The most satisfactory, both technically and economically, was to build stone islands around the pillars, against which an off-course ship could run aground. But it's not enough to merely pour a heap of stones around the pillars. Each island has to be topped with a granite shell to protect it against waves and ice. The center of the islands is made up of various size stones. The construction of these islands reduces the river's channel considerably, and this increases the speed of the current. This in turn increases the chances of the islands eroding. So a 1 meter thick protective carpeting of limestone is put around them. The size and geometry of the islands are determined precisely by mathematical models. Should a ship hit them, the blocks are designed to absorb the shock and prevent it from passing on to the bridge. At the bottom of the riverbeds, these protective shields must be 130 meters long by 100 meters wide. Once the studies have been completed, the installation of the islands begins. The materials come from 2 stone quarries. The size of the stones is checked regularly, and each one is labeled before being transported to the site. Open bottom barges are taken to the foot of the pillars and anchored above a precise spot. Then their contents are emptied in quantities of 80 tons at a time. Supervision of this type of work and its impact are very important. Throughout the operation, readings are made to verify bed deformations and follow the progress of the material's positioning. The readings are carried out from a boat equipped with a bathymeter, a measuring apparatus that, using sound waves, traces detailed maps of the bottoms of waterways. The pillars are also checked regularly to make sure the consolidation work isn't threatening the structure of the bridge. Various precision instruments are used to measure shifts, either vertically or horizontally, in the pillars. The engineers were thus able to note that the pillars were driven into the riverbed barely more than some 10 millimeters deep, in spite of the fact that more than 1 million tons of rock had been poured. The installation of the million-ton shield was no small feat for the tens of engineers, technicians, and workers who carried it out. But this bridge, which used to be the most collision-prone in North America, is now one of the most solid. For reasons relating to energy conservation, pollution, and congestion, the use of personal cars in urban centers has become a subject of some concern. The day may come when cars are prohibited in downtown areas. So if you're in the mood for a little adventure, take the subway. It offers thrills of its own.